Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So yeah, today's question is bug robot. In this question, we have a robot which is supposed to follow the instructions we have laid out for it. So we have an array A of n positive integers, and initially the robot is standing at 0, 0, facing the positive x-axis. So if this is our coordinate system with this as positive x, this is negative x, this is positive y, this is negative y. So initially robot is facing towards right direction. Then for each I from 1 to n, the robot moves a of I steps in the direction it is facing, and it is supposed to turn 90-degree clockwise. So initially, the robot is supposed to go A1 steps in this direction and turn towards the right, then go to A2 steps in this direction and turn towards this direction, and then go to A3 steps towards this direction and turn towards 90-degree clockwise, right? But unfortunately, the robot was not coded correctly and hence it cannot correctly follow the instructions correctly. So specifically, it messes up the direction to turn. So after each turn independently, it can either turn 90-degree clockwise or counterclockwise. So initially it is at 0, 0. It goes towards the right direction in with A1 steps. But after this, it can either turn at this direction as well as this direction. Then in the next step, it can turn to either of these directions. Then in the next step, it can turn to either of these directions and so on. Now we define f of a as the number of possible positions where the robot can end. For example, f of 1 is equal to 1 because the robot can only end at 1, 0. While f of 3 comma 2 is equal to 2 because initially the robot will move to three directions over here, but in its second move it can either go to this direction or this direction, right? So ultimately in the end the robot can end up into two directions, which is 3 comma 2 or 3 comma minus 2. Now we are given an integer n and we need to find that does there exist an array A such that f of A is equal to n. That is the number of possible positions where robot can end up is equal to n. And we need to, if there exists, we need to find the minimum size of such an array. And if that does not exist, we just need to print -1. And we need to note that the A can only contain positive integers. So yeah, this is pretty much the problem statement. Now let's look at the constraints once. So the number of test cases can lie in between 1 and 1000. And the number of n will lie in between 2 and 10 is to the power 9. Seeing the constraints, like the expected time complexity can be of like the order root of n or maybe log of n or something, right? Because root of n into 10 is to the power 3 would be less than 10 raised to the power 8, so it should pass. So this is something like which could be the accepted order, right? So yeah, now let's move to the sample input. So in the first sample input, we are given n equal to 2. So for n equal to 2, we can just take the same array given to us over here, which is 3 comma 2. So we can take 3 comma 2 as our array A, and the robot can end up at position 3 comma minus 2 and at 3 comma 2. So the minimum possible length of the array A would be 2 in this case. For n equal to 3, we can prove that there does not exist any possible array, so the answer is -1. And similarly, for n equal to 4, the minimum possible length of array A which we need would be 3. And you can just work on this sample test case on yourself and figure out why the answer is 3. But yeah, right now let's just move to the solution. So yeah, let's just analyze the problem in a better way, right? So initially we know that we are at coordinate 0, 0, and we'll be going in this direction with A1 steps. In a second direction, we can go either up or down with A2 steps, right? And in the third step, we can go either towards the right or towards the left with A3 steps. And in our fourth step, we'll again be either going up or down, right? So here, can you see a pattern that the x coordinate is determined by the odd positions, the odd elements of the array, and the y coordinate is determined by the even element. So A2 and then A4 to determine if it's going to go up or down, right? So the x coordinate is determined by the odd elements and the y coordinate is determined by the even elements, right? So yeah, this is the value, right? The number of possible values of A1 plus minus A3 plus minus A5 plus minus A7 dot 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 will give us the number of possible x coordinates which will end up on. And the number of possible values of plus minus A2 plus minus A4 plus minus A6 dot 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 will give us the number of possible values of y coordinates, right? And what would be the total number of values of xy coordinate? It would be their product, right? Because they are independent, so it would be their product. So the total number of end coordinates our robot can end up on would be equal to the number of possible x coordinates we can have multiplied by the number of possible y coordinates we can have. And we want this product to be equal to n, right? Makes sense, right? So now I'll just state a property that is the number of distinct, like for an array B of size k, the number of distinct values of this summation is equal to the number of possible subset sums of B1 to B2, right? And why is this true? So let's start with an example and then we'll just mathematically prove it. So let's say we have 1, 2, 3 as our array equal to B, with k is equal to 3, right? So here, the possible subset sums are not including any element, so that would be 0. Taking this element to 1, taking just this element, so the sum is 2. Taking this element, so the sum is 3. Next, taking 1, 3, the sum is 4. 1, 2, the sum would be 3. Again, 1, 3, the sum would be 4. 3, the sum would be 5. And the sum of all three elements, the sum would be 6. Now, the number of possible distinct sums we got is equal to 7, right? Now let's take this plus minus case. So we can have like all of them as positives or all these two as positives or this as negative and so on, right? So the number of distinct possible sums which we'll be getting are all of these. So 1 plus 2 plus 3 is 6. Taking 1 plus 2 and taking this as negative. So 1 plus 2 minus 3 would be 0. 1 minus 2 plus 3 would be 2 and so on, right? So the number of distinct values we got for this are also equal to 7, right? Because it's just this 0 which is repeating and rest all of the elements are distinct. So both of them are same, right? So this is like just to get an intuition about it. Now let's mathematically prove it. So let's say initially the sum of our elements a1, a2, a3, dot 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 ak is equal to this sum value. Now we can change this element, this sign to negative, right? Because it can be either positive or negative. So if we change it to negative, then our total sum will be changed by 2 times a1, right? Because one, this is subtracted and then this negative of a of 1 is added, right? So overall sum would be changed by this value. Now similarly, we have an option to like convert, change this to negative. So again, the sum would change by minus of 2. And similarly, we have all of these options for all the key elements. Now, it is like we have two options for each element. Either add this sum or do not add this sum. Similarly, either add this sum or do not add this sum into this constant value, right? So what are the total number of distinct elements we'll be getting in that? So this minus 2 is like a common element in all of them. So we can just pull this out and just take it common. So, so now we are left with this, right? So all the possible subset sums of this array can be added to this sum, and that would pretty much be like the same thing, right? So we just reduce down this problem, that is counting the possible distinct values of this to counting the possible different subset sums of B1 to B, right? Now, why did we do this reduction? How does this help? So this is like a very, very well-known property, that is, if an array is of size k, then we can get any possible distinct subset sums between k plus 1 and 2 raised to the power k. So we can always get like by putting some values of some possible values inside our array A, we can always get whatever number in between this we want as the number of distinct sums of all the possible subsets. So why is this true? So I'll just give you a brief intuition about it and you can just search over the web for the concrete proof. right? So let's say we have k items and all of them are equal, right? So what would be the possible number of distinct subarrays, distinct subset sums? So one is like not take any elements, it would be zero. Take any one, so it would be one. Take any of these two ones, so the sum would be two. Take any three ones, so the sum would be three. Take any four ones, and sum would be four. And so on. If we just take the sum of all the elements, we'll have k plus one elements, right? And what is the minimum number of elements we got? That is k plus one, right? And note that it cannot be zero or negative because the elements of A has to be positive as given in the problem. Now, in this case, we can have like to get like this 2 raised to the power k, which is the upper bound, we can just put the elements as 1. The second element as 2 raised to the power 1. The third element as 2 square. The third element as 2 cube, and so on up till 2 raised to the power k minus 1. And using this basically represents a bit of like a big number, right? So taking all the possible subsets of this, will be getting 2 raised to the power k different subsets, right? Because like either we have 0, 0, 0, 0, dot, 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 1, 0, 0, 0, 0, dot, dot, 0, 1, and we can like just take any possible subset of them and add them up. So that will be nothing but like one possible mask of like this 2 raised to the power k, right? And what are the total number of masks that we can get? That will be 2 raised to the power k, right? So yeah, this defines on like the lower bound and the upper bound. Now let's just take an example. Let's say k is equal to 3. So the minimum numbers like this would be our array, and the number of distinct sums which you can get in this case would be equal to 4. Now if you want to get let's say 5 sums, then what we'll do is we'll just make it like this 1, 1, 2. So we can get like one sum, we can get a sum of 2 by taking this element. We can get a sum of 3 by taking these two elements. We can get a sum of 4 by taking all these elements, and we can also get a sum of 0, right? So the total number of distinct possible sums which you can get would be 5. Now, if you want to get 6, we can make it this, right? We can get 1, we can get 2, we can get a sum of 3, we can get a sum of 4, we can get a sum of 5, we can also get a sum of 0, that is not including an element. So this is pretty much an intuition on why we can get every element in between k and k plus 1 and 2 raised to the k. And for a like concrete mathematical proof, you can just search over the web. So yeah, right now we have figured out that if we have an array of size k, we can get any possible distinct sums, like any possible number of distinct values that we want in between k plus 1 and 2 raised to the power k for this summation, right? So now let's see that if our array A, our initial array A is of size m, then what would be the number of odd elements and even elements? That is the possible values of x coordinates, and the possible values of y coordinates that we can get. Like what would be the number of elements in this and this? So here notice that this is just plus and not plus minus, right? So we'll discard this element completely because it's not gonna add anything to our answer. So the number of elements with A3, A5, A7 dot 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 is going to dot 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 like less than A of some k less than m is going to be equal to m minus 1 by 2. Why? So let's just take an example. Let's say m is equal to 11, right? So A3 plus A5, like plus minus A5 dot dot dot, A11 would be like the number of elements, which is 11 minus 1 by 2, that is 5, right? Similarly, for even case, it's going to be m by 2, and you can just figure this out by yourself. Now, what is the maximum possible length of m that we can get? Right, because from even the problem statement, it should be like, it should make sense that the value of m cannot be like extremely large. So it turns out that 65 is the maximum value that we can get. Why? Because what would be the number of odd elements in this case 32, and even elements would also be 32, right? Because 65 by 2 would be 32, and 65 minus 1 by 2 will also be 32, right? And if it is 32, that means we can get any possible value for our odd case between 33 and 2 raised by 32, and for our even case in between 33 and 2 raised by 32. And this 2 raised by 32 is already greater than the maximum possible value of n that we can get. So choosing this as our maximum possible value of m should be enough, right? So now how do we get the minimum value of this m? How do we do that? So for that, we can easily iterate over every possible value of m, right? So we'll iterate over every possible value of m from 1 to 65, right? From 1 to 65, we'll iterate over every possible values of m, and we'll see that can we get can we get the product of x coordinates, the number of x coordinates into the number of y coordinates equal to n using that particular value of n, right? Now, how would we get that? So we'll brute force it. So we'll be using a brute force approach. So we'll be running over all the factors of n, right? We'll run a loop over all the factors of n, and we'll see that does these factors, let's say it is x into y, right? Like if x is a factor, then the y would be nothing but n upon x. So do these x comma y satisfies this condition? That is, do these x comma y come in between this m minus 1 by 2 comma m by 2, right? This m minus 1 by 2, like this 33 or 2 raised by 32, right? Do it come in between them or not, right? Like, are these two values valid for this particular value of m? And if it is, we'll just simply print m and return. Otherwise, we'll just keep iterating for the next step. And if it is not possible for any of them, we'll simply print minus 2. So yeah, we'll just look over this once again in the code itself to make it more clear. But for now, let's see the solution in C++ first. So we'll start by pre-computing the powers of 2 just to increase the time complexity, just to make it faster. So we are pre-computing all the powers of 2 up till 65. And then we are running a loop for each test case where we are calling to solve for this particular value of n. We'll get all the factors of n. Now this x parts and y parts denotes the number of elements in the odd case and the number of elements in the even case, and the possible range of elements which I can create by putting in some values inside my array would be x parts plus 1 for this x coordinate, and this 2 raised to the power x parts for this would be like the upper bound for this x coordinate, right? And similarly for y, this y parts plus 1 would be like the lower bound for the possible values of y, and 2 raised to the power this y parts would be the upper bound, right? Now we'll iterate over all the factors of our n, and if this x is greater than or is in between Lx and Rx, and this y is in between the Ly and Ry, that is the limit on y, and this is the limit on x. That means there exists a possible value, a valid value, so we'll return m. Otherwise, we'll be returning minus 1. So this is the whole solution in C++. The time complexity is 65 into root of n for each test case, because we are running like there would be like almost roughly root n factors, and we are running a loop up till 65. So this is the whole solution in C++. Now let's see the solution in Python. So we have defined the maximum possible value of m as 65. We are running a loop for each test case and calling this function solve. We're taking an input of n. We're getting all the factors of n in square root of n time complexity. So this will return us all the possible factor pairs of n. Then we are getting the x parts, that is the number of elements which would be there in the x coordinates. And this is the y parts, which would be the number of elements in the y coordinate. And this Lx and Rx are the upper and lower limit for the x coordinates. And this Ly and Ry are the lower and upper limits for the y coordinates. Now we're iterating over the factors of n. And if this dx, that is like the first factor, is in between the x coordinates, and this dy is in between the y coordinates, that means this particular factor is a valid value for this particular value of m. So we'll print this m. and return. Otherwise, if we cannot find any possible value, we'll print -1. So this is pretty much the whole solution. The time complexity is 65 into square root of n for each test case because maximum n is 65 and the number of factors can be at max square root of n. So yeah, this is pretty much the whole solution. I hope you liked it. Thanks. Bye bye.